So in this question, we have to find the domain of the following functions and how many parts? 1, 2, 3, 4 parts. So let's begin with the first part. Now, first of all, you should know what is domain. Domain are those values of x for which the function is defined. So what you can see that this is our first function and this is an under root expression, right? Under root function. So what we know that the expression which is inside the under root ordinarily we write as greater than equal to 0, but over here we'll be writing greater than 0. As you can see that it is in the form of p by q where q cannot be 0. Now that's the first thing that we do, and now I'm going to factorize it. We can say that we can use middle term minus 2x minus x plus 2 greater than 0. So I split minus 3x as minus 2x minus x. Further, if I take x common, we get x minus 2. And if I take minus 1 common, I'll get x minus 2 greater than 0. So taking x minus 2 as common, and we get x minus 2 into x minus 1 are the two factors. So the two values of x are 1 and minus 1. There are different methods of finding out the domain. Over here, I use a number line. So minus infinity to positive infinity, and in between, I'll place 1 and 2 as the zeros. Now, next, what I'll do, I'll just place a value in between minus infinity to 1, and we'll check whether it is satisfying this relation or not. So that means greater than 0, not a relation. If I talk about minus infinity to 1, I can take 0. So placing x as 0, I'll get minus 2, and this as minus 1. So that's positive. So I'll say yes, that is true because we need greater than 0. Now a number between 1 to 2, if I place 1.5, this is 1 minus 1.5 minus 2 is negative 0.5, and this is positive. So it will give you negative. From 2 to 3, if I 2 to infinity, if I place 3, 3 minus 2 is positive, 3 minus 1 is positive. So that is positive. So for domain, I'll say domain of this function will be what? That is minus infinity to 1, open interval, and union this one, that is from 2 to infinity. Make sure you are putting a open interval and not a closed interval because this is greater than 0 and not greater than equal to 0. So this is for the first part. Now if I see the second part, in the second part, this is the function over here. You can see that x is inside a modulus function, right? So you know that x can take any real values, right? Here x can take any real values. So we'll say that the domain of this function belongs to R. Now check for the third part over here. If I see the third part, similar to the previous question, not the previous, the first one, we have to write this expression which is inside an under root as greater than 0. So we are doing the third part now. In the third part, we'll be writing x square minus 25 has to be greater than 0 and not greater than equal to 0. So here we'll factorize x minus 5, x minus 5. As you know that it is in the form of a square minus b square. So x is equal to 5 and 5. So now what we do is to make a number line with negative infinity over here, positive infinity. In between we have 5 only. Oh, what I did, this was a square minus b square, right? So it should be plus 5 minus 5. So this is going to be, let's say, I'll place minus 5 and plus 5 here. So in the interval this, let's say if I place minus 6 over here, I'm going to place minus 6 over here. So this will be minus 6 minus 5 is negative, and this is also negative. So negative into negative is positive. In this interval, I can place 0. Placing x as 0, we get negative. Placing x as 0, I'm getting positive. So that is negative into positive is negative. 5 to infinity, I place 6, positive. 6, positive. So positive into positive is positive. So the domain in this function will be is what? Is minus infinity to minus 5, open interval, and union 5 to positive infinity. That should be the answer for the second part. Well, this was the second part. Sorry, this is third, right? In order it is third. We did the third part over here. Now we have one more Now in the fourth part, as you can see that this is again an under root expression, but this expression has two under root. So let's begin with solving the first under root, the expression inside this under root, which is x minus 3 minus 2. This is 2 whole under root x minus 4 has to be greater than equal to 0 and not greater than 0, right? Now, as I said, there is another under root expression. So let's resolve that part also. This expression also has to be greater than 0. So I'll write x minus 4 as greater than equal to 0 and not greater than 0. This implies that x is greater than equal to 4. Now check by substituting x as the minimum value that x can take is what? 4. So let's plug in x as 4. So this is 4 minus 3 minus 2 times under root, replacing this with 4. So 4 minus 4 is what? So 4 minus 3 is what? 1 minus 2 times, and this is 0. 0 is greater than. So we say that 1 is greater than equal to 0. So we'll take this as the domain. So domain for this part, that is domain of this function, has to be what? 4 greater than equal to 4. So minimum value it will take is 4 and maximum infinity. So this is what the domain for the fourth part.